Let's do some small hands-on on MapReduce. And you do not have to do this. You do not have to do any hands-on on MapReduce. The reason I'm pulling this up is because I want to show you something about the problem of MapReduce. What is the biggest challenge that MapReduce has? Because I have been talking about MapReduce for quite some time now, and you must feel that MapReduce is a distributed processing framework, which is very good and it does the job really well. But why we are not using MapReduce anymore, or why the organizations are tilting or moving towards Spark? There is one major reason for it, and that's what I want to show you in this hands-on. Again, you don't have to do this. If you want, you can download the code, download the file and run it on your own. And this is what we are going to do. There would be an input file, and from the input file, you'll have to define the key and corresponding value. Remember that we'll have to use key value because the sorting, the partitioning, the copying, the reducer, or the aggregation, everything happens on key value. So I'll have to create a key value from an input file. The input file that I'm going to use would be a CSV file. So I'll be creating a key and its corresponding value. The value can contain one column or multiple columns. And then I'll run a map task or a mapper task using Python. So I'll not be using Java, I'll be using Python to run a map task. And what it would do, it would create some temporary files, and the files would be either sorted or partitioned based on the key. And the files would also contain key value. And the number of rows can be less or more or same. In our case, the hands-on that I'm going to show you, in one of the use cases, it would contain a lesser number of rows, but for all the other use cases, it would contain same number of rows. And then there would be copy phase, and individual partition blocks would be copied to the reducer nodes, and there it would be merged and sorted, and then the reduce task would run, and eventually the output file would be written, which would also contain key and value. So this is the high level anatomy of how MapReduce works. Now here I have mentioned these temporary files in red. Why that is the case? Because the temporary files can get really big. And imagine that you have hundreds of GBs of input file, how big the temporary files can get. And that is the purpose of this hands-on, by the way. I want to show you the temporary files and its corresponding size. Not only that, the map task is performing IO operations or input-output operations, wherein it is writing data to files on the disk. And then those files or blocks from those files would be copied to the reduce nodes or reducer nodes, and there also those partitions for a particular reducer would be merged and sorted and written to a file. So another disk IO. And finally, the output of the reduce task would be written to an output file. Now, if I look at this very simple workflow or a very simple pipeline of this MapReduce job, I have one IO here where the map task would read the data from the input file. This is the first IO. The second IO would be writing the records after the map task is over to these temporary files. This is the second IO. Then the files would be copied over to the reducer node, which is a data transfer over the network. And there also temporary files would be created, and the reduce task could read from these temporary files. Another IO, which is IO number 3. And finally, it would write to the output file, which is IO number 4. So with a single map and a single reduce task, we have at least 4 different IOs. And if the size of the files are big, then obviously the IO operation would also be big. And as you might already know that the biggest challenge in any system is, or the biggest bottleneck of any system is IO. Anyway, so let's look at this in action. I'll not use a very big file. I'll use quite literally a very small file to show you the size of the temporary files and the number of temporary files that are created. And these are the use cases that I'm going to perform. First, I'll have to install something called mrjob, which is MapReduce job for Python. So using mrjob, we can write MapReduce jobs using Python. And you might already know how to install a library. We'll have to use pip or pip3 followed by install followed by the name of the library. In this case, it is mrjob. Then we'll have to install something called setup tools also. If you do not install setup tools, then you might get error in the mrjob, which would be an internal error and we cannot debug it actually. So better to install setup tools. And then these are the logic that I'm going to implement. In the first logic or in the first use case, I'd create one mapper or one map task which will define the key and value, and one reduce task which will count the number of passengers by country. What is this number of passengers by country? You'll be able to see this when I show you the file. In the second logic, again, I will create one mapper and one reducer. The map task would contain or have a logic to define the key and value, and the reduce task would do an aggregation which will find the total spend by a country. Then in the third logic, I'll have two map tasks. So two mappers, no reducer. I'll define the key value and I'll select records only from a specific country, which is a filter condition. So these are the three logic that I'm going to implement and show you how MapReduce works. I'm calling it out again. You do not have to do this. You can just watch this video and conclude this MapReduce topic. If you want, you can do the hands-on also, because I'll be giving you the code and the files. Okay, so I have opened PyCharm ID and let me show you the file. This is the file which is flight_data.csv. It contains flight data. That's why I have country and count. And the schema contains in a different file which is flight_data_schema. And you can see that it contains departure time, arrival time, flight ID, flight cost, origin airport, passenger name, passenger country. So this is the country that I was talking about. And I want to find out the total number of passengers per country. That is the first logic. And in the second use case, I want to do a summation of the flight cost by a country. So it should be passenger country. And in the third case, I'll be filtering based on a passenger country. So I can mention any country name. So as you can see that I'm using passenger country in all the cases. So what would be the key here? You can pause the video and think about it. What would be the key? Would it be the flight ID, aircraft ID, itinerary number, or anything else? All right, I hope you are done. So the key would be passenger country, because I want to find out the total number of passengers per country, and I also want to find out the total cost or total spend by an individual country. So that's why the passenger country would be the key, and the value can be the entire row, all the columns of the entire row, or I can find or I can get only one column. And this is the code. As I said, you do not have to worry about the code. If you want to execute this code, you can go ahead and do that. So what the code is doing, it is importing something from mrjob.job, and it is importing this class called mrjob and another class called mrstep. And then I'm importing the CSV module because I'll be using the CSV module later on. Then I am creating a class which is inherited from mrjob, and the name of the class is MapReduce job. Maybe I'll name it as MapReduce job tnayam. So this is the name that I have given, but what this class is doing, this class is inheriting from mrjob class. All right, so after that, what am I doing? I'm creating the key and the value. As you can see in the entire code, I'm not reading the file at all. Nowhere I'm reading the file. So what this framework would do, this is a map task. So the file would be sent, or the records in the file would be sent one by one in the line variable. And if I want, I can send the key also. If I want to ignore the key, that is also fine. And then I'm reading the record, and I have to read it using CSV reader because I'm using a CSV file, and the key is record 14. So what is this record 14? Let me go to flight data schema, and this is passenger country. Why it is 14? Because the index starts from 0. So this would be 0 and passenger country would be 14. So the key would be the passenger country, and the value would contain record seventh element of the record. Let's see what is that. And that is the flight cost. So I'm fetching the key as the passenger country and value as the flight cost. Then I'm using a keyword called yield rather than return, and I'm yielding key and value. By the way, this is a method which is a function inside of a class. As this is a function, I'll have to return something, but instead of returning, I can yield also. There is a big difference between yield and return. What happens is that if we use yield instead of return, the function is not terminated, the state of the function is saved, and then it would start from the same state, meaning that as I have multiple lines, right, I have, I think, around 5 million rows in that particular file. So for each individual record, this function would run. This is the transformation function that I have created. This is defined by me, not the framework. So that's why as this function would be executed for each line, the function should know what was the last line that it executed. If I use return, then what would happen? Every time it would start from the first line and the state of the function would be gone. So that's why I'm using yield, which will save the state of the function and it would start again from where it left off. So what would happen? The first row would come, it would do the processing and it would return or yield the row, and the state would be saved saying that, okay, I have read the first line. Now when it is called the next time, the second row would be read, not the first row, because as I'm using yield, it knows which row was executed just before this one, because the state is saved. So the function is not terminated, the state is saved and it is resumed again where it left off, right? So that's what yield does, and without yield, if we use return, then actually it will not work. All right, so what I'm doing, I'm yielding the key and value, or I'm returning the key and the value variables, keeping the state of the function saved. So that's what yield is, return with the state of the function being saved. So the first row would be done, the second row would be done, and all the 500,000 rows would be done, right? And the key would be the passenger country and the value would be the flight cost. So this is the first function, which is a map function. As a best practice, you should always name the map functions or map tasks with map underscore. Okay, then I have defined another map function wherein I'm just returning the key and 1 because I want to count, right? So that's why I'm sending 1. Then I have another function or another method which is reduce count by country, and here what am I doing? I am doing some aggregation. So I'm adding all the counts for a particular country, and then I am also doing aggregation of the cost because I want to find out the spend by a particular country. And then I have another map function which is actually filter country. I should name it as map underscore filter underscore country. What I'm saying here is that if key equal to India, then the country key is equal to key and country value is equal to value, and I'm returning the country and its corresponding value as the output, right? So these are the 5 different methods that I have defined. Now how do we execute this? And that's where this is important. I'll have to define the steps. And here I'm returning an array and I'm returning multiple steps using mr step. And here I define what would be the map step and what would be the reduce step. So if you see here, I have commented the first one. Here I have one mapper and one reducer. So the map and reduce would be executed. So this map function, which is map underscore key underscore value, would be executed. And then the reduce function, which is reduce underscore spend by country, would be executed, which is this one. So the first would be map key value, which is this method that will get executed. Then this reduce step get executed. Now how the framework knows which is the map task, which is the reduce task, using these keywords mapper and reducer. So this is the first use case. Then this is the second use case, which is reduce count by country, and this is reduce spend by country. Reduce is basically aggregate. And then I have 2 map tasks. So let's run them one by one, and I'll have to change this particular name. I'll have to use this class MapReduce job 3 I am, and I have to use this method run. Now I cannot press play here. I cannot execute it like this. Now to execute this, I'll have to use the command line. All the commands are given in the command sheet, and this is the command sheet for data processing framework. The first one is MapReduce using Python. I have given all the commands that you have to run, right? And this is how you execute the code. Now here, the only things that I have to change, let me mark it as red, then you'd know what you have to change. You will have to mention the temporary directory. So what am I doing here is that I'm mentioning something called temp directory, and I'm mentioning something called step directory. And this is the input file that I'm providing, and you can name your output file also. These are the things that you have to change. All right. And then I have SDFS commands also, which is basically for the second hands-on that I'm going to show you. Okay, so let's execute this. But before that, you'll have to install mrjob and setup tools. pip3 install mrjob. I hope you know what am I doing. If not, please go through the Python essentials course, which is a prerequisite. And as I have already installed, it is saying requirement already satisfied. Likewise, I can install the setup tools library also, which is also installed already. I have already installed the previous one, right? Okay, so now let me go ahead and execute this particular code. But before that, this is the directory that I'm in, Python MapReduce, and here I have these three files: flight data schema, flight data.csv, and python underscore MapReduce underscore job.py. Let me show you the size of the files. This is how you get the size in a Linux machine. And if you have Windows machine, you can do a right click and check the size in the properties. So the flight data schema is 4K. Obviously, the size is very less. The flight data is 593 MB. And this is the code. Now I'll have to execute the code. And this is the command to execute the code. So Python 3, Python MapReduce job.py. You have to mention r equal to local because I'm running the MapReduce code in my local machine. That's why you have to mention -r local. Cleanup equal to none, meaning that all the temporary files should be there. And that is the purpose I'm showing you this hands-on. And then I'm mentioning verbose so that all the comments and all the messages are shown either in the terminal or in the file. Then I have local temp directory, which is a directory where the temporary files should be stored. Now, what are the temporary files? The files that I had shown you in red, that is the temporary file. And then we have step output directory, which is another temporary file. And this is the input file. And let's name the output file as use case 1.out. Okay, so I'm passing the input file here. Now, as I told you already, in the code, I do not have any logic to read the file. As you can see, if you look at each and every line, I'm not opening the file. I'm not opening any file. I'm just running the MapReduce code. Okay. All right. So now what it would do, it would execute the program. Hopefully there's no error. And once the execution is done, it will write the output in use case 1.out. The job execution is complete. And let's look at the output. So this is the first output. And if I open, I have this country name and then the total spend. And that's what I'm doing here, right? I am creating the key and the value, and then I'm aggregating the spend by country. So that's what it is showing. I'm not sorting. I'm not doing anything as such. So this is the spend by all the countries that are there in the file. So this is the first use case that I have implemented. As part of the second use case, I'll define one mapper, which will again define the key and value, and the reducer would find the total spend by country. Actually, I have done the second use case as the first. Let's implement the first use case, wherein I'll define the key value using a mapper, and the reducer will aggregate and give us the total count of passengers by country. And for this is not the step, this is the step. Again, what am I doing here is that I'm running this map, which is map count by country, and I am using this reduce, which is map reduce by country. But there is a problem. Let me go to the map count by country method. And this is the method. Here I'm supposed to pass the key and value because the key is essential, and I have to pass the country. So if we do not create the key, or if you do not provide the key as country, what would happen is it will error out because I have not made the key. So that's why I'll have to add one more step wherein I'll just run the mapper and it would just create the map key value, right? So this is the first step and this is the second step. Now before executing this, let me show you one more thing. Okay, as you can see here, some file has been created which was not there earlier. And if I open this, I have this output wherein I have multiple partitions, but these many map tasks got executed and created so many partitions for the reduce. And then you have steps. Here I have mapper, and these are basically, this is the input file, this is the output file of one mapper, this is the second mapper, input file and output file. So as you can see, so many files have been created, right? And if I look at the size now, this is the temporary file, and as you can see, the size is 772 MB, which is more than the input file, which is only 593 MB. So this is a huge overhead. That is what I was trying to show you. This is the temporary file. So now what will I do? I will delete this file, or I will remove this particular directory completely, and I'll keep all the remaining files. Now another directory would be created with the name of the program, then the username, followed by the date and the time. Okay, but here what am I doing? I am running two steps. This is the first step, which is map. Then in the second step, we have map and reduce. So this is M1, this is M2, and this is R1, right? Okay, so let's go ahead and execute this. And I'll have to do this using the command line. And let's mention this as use case underscore 2.out. Hopefully it will not error out. And I'm confident because I tested this. So let's see the files. Again, I have this temporary file whose size is 781 MB. And let's look at the output file, and it is showing the count of all the countries that the file contains, right? So this is the count is done, spend is done, and this also created temporary files. But here we have one additional temporary file. So what this directory is for the partition, right? And then we have this step. We have two steps. This is the first step wherein I'm running only mapper, and these are all the partitions. You can see the input file. And then we have another step wherein I have mapper. These are the files of the mapper. You can see the input, and this is the output. Don't worry about the input and output. And I have a reducer also. And these are the sorted and merged files that I was talking about. Finally, let's run the last use case wherein I'll run two map jobs. This is the first step. I have to create the key and value, and then I'll filter the country. And the country name is India, right? Okay, so let's go ahead and execute this. Same command, only the output is different. Okay, I got an error. It says the object has no attribute filter country. Did you mean map filter country? There's no method named filter country. I changed the name to map filter country. So that's why the error is. And let's execute this again. Execution is done. Let's see the output file. So this is the output file whose size is 654 MB. And let's look at the files. I have multiple steps. This is the first step, or step number 0. This is the second step, or step number 1. It runs only mapper, no reducer. As you can see, there is no reduce folder. But in the previous case, I had a reducer also in the second step rather, because I was running one reducer. But in this time, in this particular use case, I do not have any reducer in any of the steps. So this is the mapper. This is the first map, and this is the second step, which is also running another mapper or map task, because I'm running two map tasks, right? And this is the output, which should contain records only from India. Okay, so this is how MapReduce works. And what does that tell you? What is the problem that I was talking about? The problem is these temporary files and lot of IO. So with 600 MB of file, every time the temporary file size were higher than the input file size. So let's say you have 500 GB of input file, or let's say 100 GB of input file. The temporary file should be anywhere between 120 to 150 GB, both these files. So you're doing an IO on 100 GB, then an IO on 120, then IO on 120 again, let's say, and then finally 100 GB or maybe less. So 240 GB is unnecessary. Now imagine I have a MapReduce complex job like this, which I can do, right? I've shown you how to create the steps, how to run the steps, etc. So let's say I have two mapper and then one reducer, and this upper MapReduce task, mapper reducer, and then lower line also contains mapper reducer, and then reducer, finally mapper, where the IOs would be. I'm not showing you the input and output files. Without the input and output files, these are the places where the MapReduce task would write to temporary files or read from temporary files. So imagine the number of IO that would happen if the input file size is, let's say, 100 GB and 100 GB. This would be 125, this will be 125, let's say 250 plus maybe 100 GB, 350 plus 375 plus 375 plus maybe 100 GB. You do the math. For only 3 files, so many IO are happening. And that is the exact problem with MapReduce, that at every step, it writes to the files and reads from the files. And that's why MapReduce jobs take a lot of time, and it is good for batch processing. Even today, we use MapReduce in the form of Hive. What we do is that we run batch jobs using the MapReduce framework. Now the jobs can run for hours or even days. I have seen MapReduce jobs running for days also. Now because of this problem, this IO problem that I'm talking about, which is a major one, Spark has overtaken MapReduce as the go-to solution for data processing. Now before talking about Spark, I wanted to give you some history about the other big data processing. So that's why I have shown you MapReduce. Okay, and again, you do not have to write the code, you do not have to understand the code. Even the mrjob library that I'm talking about, it is at version 0.7.4 if I'm not wrong, as of the time of this recording. It is not yet in version 1. And I have never written any MapReduce job using mrjob earlier. This is the first time I have written using Python. I hope you understand what I'm trying to say here. The problem is the IO, right? And that's why MapReduce creates huge problem in today's fast-paced application and fast-paced world.